Okay, let's dive into this. You know, when we talk about the dangers of AI, our minds probably jump to one of two places, either this amazing robot paradise or, a full-on sci-fi apocalypse. But today, we're going to talk about a risk that's way more immediate and kind of hidden, one that's already shaping our world in ways we don't always see. This warning, and it comes straight from our source material, really sets the stakes incredibly high. The author isn't worried about AI research losing funding. That's the so-called AI winter. No, they're worried about a nuclear winter, a massive, catastrophic failure caused by the very systems we're building right now.
So what is this nuclear winter they're talking about? It's not killer robots, I promise. It's a really fundamental issue right at the heart of artificial intelligence, a concept that the experts call model risk. And this, right here, is the absolute core of the problem. We're building these systems that are just brilliant at matching patterns, but they have zero actual understanding of the world. They can be incredibly certain and, at the exact same time, be incredibly wrong. And our blind trust in what they tell us, well, that's where the real danger is hiding. To really see this in action, let's look at a famous, and honestly, a pretty baffling example of AI's blind spots. I think this will make that abstract idea of model risk crystal clear. So first, let's just get the official definition on the table. Model risk is simply the danger that comes from making a bad decision because a model, an AI, an algorithm, gave you flawed information. It's that gap between the model's neat and tidy world and our messy, complicated reality. To really get this, let's use a classic example. Picture two images of a school bus. To you and me, they look completely 100% identical. Any person, even a little kid, would look at both and say, yep, that's a school bus. Okay, so the human sees a school bus. Easy enough. But what about a cutting-edge computer vision system? Now, that second image has been altered with a teeny tiny bit of digital noise, something that is totally invisible to our eyes. So what does the super smart AI see? It sees an ostrich. Yep, an ostrich. With 99% confidence, the AI declares that this school bus is, in fact, an ostrich. Now, what's so fascinating here is what this shows us. The AI doesn't see a bus. It just calculates a probability based on a bunch of pixels and patterns. You change that pattern just a tiny bit, and the whole house of cards comes tumbling down. And this perfectly illustrates this idea of brittleness. It's funny when it's an ostrich, but it gets absolutely terrifying when you realize this same fragile logic is being used in the real world, powering financial trading algorithms, self-driving cars, or security cameras. A tiny, unseen error can lead to a huge, catastrophic failure. I mean, this quote comes from an analysis of a fatal self-driving car accident. The system wasn't dumb, it was brittle. It came across something it wasn't perfectly trained on, and the result was a tragedy. In that case, the AI didn't see an ostrich, it just saw nothing at all. And this really gets us to the heart of the matter. You see, the problem isn't some simple bug we can just fix with a patch. It's a fundamental difference in how machines think versus how we humans understand. Think of it this way. AI lives in the world of pure mathematics. It's an information processor. It looks backwards at historical data, all inside a world it assumes is known and certain. But humans, we're sense makers. We use our intuition, our gut feelings to try and anticipate an unknown, uncertain future. Einstein said it perfectly. Math is this beautiful, clean, perfect language. But reality? Reality is messy. An AI model is an abstraction. It's a simplified map. And as we all know, the map is not the territory. So the crucial point is this. An AI can master the incredibly complex rules of the game Go, which is an amazing feat of pure information processing. But it has absolutely no common sense. It doesn't know what a game is or what a table is or what would happen if you just pushed the board right off the edge. It's got calculation, but zero context. So what's the answer? Do we just give up on these powerful tools? No, not at all. The answer is all about managing this weakness, about building systems that acknowledge the limits of pure math. There's a famous saying in statistics, and it's the perfect mindset for this. All models are wrong, but some are useful. We have to start with that assumption, that our AI models are flawed. Their usefulness doesn't come from being perfect. It comes from being a helpful tool for a human expert. And that brings us to the hero of our story, model risk management. See, this isn't about writing better code. It's about having a better process. It's a framework that intentionally brings human wisdom, our subjectivity, and plain old common sense back into the equation to sanity check the objective output of the machine. Let me tell you an incredible true story that is the ultimate example of this. Back in 1983, Soviet early warning computers reported 5 incoming American nuclear missiles. Protocol, the algorithm, was crystal clear: launch a full-scale counterattack immediately. But Lieutenant Colonel Stanislav Petrov had a gut feeling. A 5-missile strike? It didn't feel right. He trusted his intuition over the machine, reported it as a system malfunction, and single-handedly prevented World War III. And this was his explanation. He said, "We are wiser than the computers. We created them. The computer was just following its programming. But Petrov had context. He had intuition. He had common sense. He understood the world in a way the model never ever could. He was the human in the loop."
So where does all this leave us? Well, it points to a future where our relationship with technology is all about partnership, not replacement. This right here is the key takeaway. AI is not an artificial mind. It's a force multiplier for the human mind. Think of it as an unbelievably powerful calculator that can spot patterns we'd miss, but it requires a wise human to interpret those patterns and make a final judgment call. And this brilliant quote from the source material just sums it all up perfectly. As technology gets smarter, the value of human wisdom, intuition, and critical thinking doesn't decrease, it skyrockets. The real competitive edge is going to belong to those who know how to use these new tools with discernment and judgment.
So I'll leave you with this question. We're all using algorithms every single day, from our navigation apps to our news feeds. So when the data on the screen points one way, but your intuition, your gut is screaming the opposite, which one do you follow? The story of Stanislav Petrov shows that sometimes the fate of the entire world can depend on that choice.